Hi there, and welcome to this week's Form Time Numeracy Challenge. Here is your first question. Pause the video for as long as you need. Now moving on to the second question. You might want to make a note of those 11 numbers at the top because you're going to need those for the second part of this as well. Pause for as long as you need and moving on. Okay, that one's going to take you a little bit longer, I think. So pause for as long as you need. Now let's take a look at the answers. Firstly, question 1. Okay, so we are given this fact here. Okay, so if we want to know what 233,343 divided by 99 is, okay, we need to work backwards and we're going to get this answer here of 2,357. Okay, this time, this number is 10 times smaller. We've got a decimal point in here, so we've moved the place value once. So that leaves us with a solution that needs to be exactly 10 times smaller than 233,343. So our answer is 23,334.3. Okay, let's move on to question 2. Here are our 11 numbers. So a prime number, we've got either 23 or 29. Cube numbers, we know that 2 cubed is going to be 8. 4 cubed is going to be 64. So we've only got one solution, that's 3 cubed, which gives us 27. And for square numbers, again, only one solution, 5 squared gives us 25. Now, the second part of this was a little bit more challenging. Let's take a look. So Fibonacci, okay? When we're doing our Fibonacci sequence, we're adding the previous number, okay? So 1 plus 1 gives us 2. Then we're adding that 1 to the 2 to get 3. We're adding the 2 to the 3 to get 5, and so on, okay? So I've got to add the 8 to the 13 to give us 21. If I then added 13 to 21, that would give me 34, and it's too large for the available numbers up here. Triangular numbers, okay? What you'll see here is there is a pattern because we're adding on another row at the bottom. We've added on 2 extra circles there, 3 here, 4 here, and 5 here. Okay, so plus 2, plus 3, plus 4, plus 5. So we've got to add on 6, which is going to give us 21, or add on a further 7 would give us 28. Perfect numbers. There's actually only 4 perfect numbers that are less than 1 million. And I believe they've only ever found 50 perfect numbers at all. So a perfect number is when you take all the factors of a number, not including the number itself, add them together and they equal the number. So for example, number 6, factors of 6, 1 and 6, 2 and 3, add 1, 2 and 3. That gives you an answer of 6, which was your original number. Therefore, it is perfect. There's only one number in this sequence. It's 28. So the factors of 28 are 1 and 28, 2 and 14, 4 and 7. Remember, you don't include the number itself. Add up 1, 2, 4, 7 and 14, and you're going to get 28. The other 2 numbers, less than 1 million, that are perfect are 496 and 8,128. I wouldn't suggest you look at those now, but those are the only 4 numbers that are less than 1 million that are perfect numbers. And finally, a powerful number is a number that has a prime number that divides into the number, but also the square of that prime number divides into the number as well. So for example, here you've got 16, okay? 2 is a factor of 16, and 4, 2 squared, is also a factor of 16. So you can either have 25 or 27 as your answer. That's because the factors of 25, there's a factor of 5, which is a prime number, 5 squared gives me 25. Okay, or 27, because 3 is a prime number, 3 squared gives me 9. Okay, you cannot have 24 because although it's 2 squared gives you 4, 3 squared gives you 9, and 9 is not a factor of 24. Okay, that's all from me today. Thank you very much.